Hello everyone and welcome to this presentation titled Securing the Query, Understanding and Preventing SQL Injection. This is a deep dive into SQLi and how to safeguard your web applications. Hello, I'm Shir Das and this is a part of Database Fundamental Unit 772. Let's take a deep dive into what SQL injection is, the risk it presents and how we can protect our applications from it. So what is SQL injection? SQL injection is a code injection technique that manipulates SQL queries to execute unintended commands. It allows attackers to manipulate SQL queries, gaining unauthorized access to data, altering records, or executing administrative commands. Essentially, an attacker can manipulate SQL queries to access or modify data in unintended ways. Here's an example. Let's say we have a query which selects all from the users where username is input and password is also input. Now if a user enters apostrophe or 1 equals to 1 as username, the query becomes select all from users where username equals to empty string or 1 equals to 1 and password equals to empty string. Now this is logically true for all rows as we have a OR with 1 equals to 1 which is always true. By this, the attacker logs in without any valid credentials. This kind of vulnerability can lead to unauthorized data access or even total control of the database. There are several types of SQLi attacks. The first one being in-band SQLi, where the attackers uses the same communication channel to launch the attack and gather results. There are two types of in-band SQLi, the number first being error-based SQLi, where attackers relies on the error message to reveal the database details. The next we have union-based SQLi, where attackers uses the union command to retrieve data from other tables. Then we have inferential or blind SQLi, which doesn't reveal the data directly but infers it through application behavior. In this, we have first Boolean-based blind SQLi, where attackers uses true or false queries to guess the data. Then we have time-based blind SQLi, where attackers measure the delay in response to, to gather information. And at last, we have out-of-band SQLi, which is used when none of the other works for it. In out-of-band SQLi, the attackers sends data via different channels like DNS or HTTP to exfiltrate data. While each type of while each has its unique characteristics, but all can be devastating if not addressed. So why do these vulnerabilities exist? The main causes include lack of input validation. Applications don't properly check or clean user input, or use of dynamic SQL. Directly including user input in SQL strings is a major risk. Also, we have export error messages. This can unintentionally reveal database structure to the attackers. We also have excessive privileges, like allowing unnecessary permission that can escalate damage if exploited. Understanding these causes help us to take first step toward prevention. While we will talk about the prevention in the further slide, let's see the consequences of SQLi and how severe can it be. First, we can have data breaches where sensitive information like passwords or credit card number can be stolen. Then we also can have data loss or corruption from unauthorized deletion or modification. We also could have privilege escalation, giving attackers admin level control. And obviously there will be service disruption, possibly leading to denial of service. We also could be in legal or regulatory fines, especially under data protection laws. And finally, reputational damage, which can be devastating for any organization. Clearly, these are not a threat to be taken lightly. Let's look at two real-world examples. Number one, the 7-Eleven ATM breach between 2007 and 2008, where SQLi was used on a public website to access backend service of ATMs. Malware, Malware was installed to collect card data and pins to withdraw nearly $180,000, which linked to steal over 130 million card records. Then we have the Talk Telecommunication Bill of 2015, which also resulted from SQLI. Injection allowed you access to customer databases. Over 150,000 customer records were compromised, including thousands of bank details, which was caused due to the patches update. The company had faced a fine of £400,000 and major reputational and financial loss. These examples highlight just how real and dangerous SQLI can be. Fortunately, there are many ways to protect against SQLI. The number one being use prepared statements. This gives user inputs separate from the SQLI logic. Also, we can validate inputs, like always check for type, length, and format of the inputs. We can also limit privileges, like use the principle of least privilege, giving only what's necessary. Then we can hide errors, like we don't need to expose our errors to the users, just log them internally instead, maybe. Yeah. We also have web application firewalls, which can filter out the attack patterns. We can go further and do code audits, like regularly reviewing the code for vulnerabilities. And most importantly, developer training, which ensures to equip your team with secure coding practices. Combining these strategies significantly lowers the risk of SQL injection. To conclude, SQL injection is preventable, yet pervasive threat that continues to impact web applications. By understanding how SQL works and adopting best practices for secure coding, organizations can reduce the risk significantly. It's important to ensure regular code reviews, implement proper input valuations, and use strong security measures like prepared statement and web application firewalls. Although SQL injection remains a persistent risk, web applications can be effectively secured with proactive and consistent security practices. Thank you for listening. Bye bye.